Welcome everyone to the IXUS 2024.3 release highlights webinar. So this is our final release of the year. We're not going to add another one after this one just before the new year. But obviously we're continuing the working on the next release as well. So we'll be going through just the highlights of the features that we've implemented, and then follow that with a nice demonstration, let's say in the modeler and so on. Okay, so the version is 4.13.0 or 2024.3, and here you can see just a few of the highlights that we have implemented, but I'm not going to mention them now. We're just going to go through the slides which have a bit more detail on each individual section. Okay, so new features and enhancements. So the first one to mention is the single point source method for far field calculations. So don't want to go into too much detail here, but essentially what it boils down to is that with our ray tracing antenna models, this consists of multiple point sources within the antenna that is then calculated to form to determine like what the exposure is at certain distances, and that's very, very beneficial when calculating values close to the antenna because it's a more realistic representation of what an actual antenna, like the actual antenna behavior. However, once you get into the far field of the antenna, or like far away from the antenna, the benefits of that starts diminishing. So what we've implemented is what we call the single point source method, where in the far field, instead of calculating the exposure using these multiple different point sources within the antenna, we represent that by a single point source. And the benefit of that is obviously it's going to be calculation speed improvements, in particular, obviously, in the far field. So when you have multiple antennas where some of the antennas are in the far field of another antenna, or just the exclusion zone is larger than the far field, or environmental status far away from the site, you will see the benefits of that. Yeah, so in practice, faster calculations. Okay, so the next one is the initial mesh size adjustment for better calculation performance of exclusion zones. It's a mouthful. I'll try to keep this brief because it's a bit complex to explain, but essentially the starting mesh coarseness, which later gets refined, but the starting mesh has been adjusted to be better suited for very large exclusion zones. For example, the 5% of public exclusion zone. Because these exclusion zones are very large, you do not need very fine meshing to represent that. So the starting mesh, we've made that a bit more coarse. It still gets refined where necessary, but due to that enhancement is that the exclusion zones like this will be much faster to calculate. We have made some adjustments to, for example, the public exclusion zones as well, and actually 10x occupation will make it more fine, but in general you should see better performance in terms of calculation speed. As an example, this specific site was calculated, I think with the previous release I measured around, let's say, 4 minutes or something for when you're calculating a 5% public exclusion zone. That is now down to around, I think, 30 seconds or 40 seconds. So it's much faster. Obviously, it will depend much on the specific site that you are simulating. Next feature is a very important one, directional EMF attenuation or segment attenuation. So this allows the user to specify segments with attenuation for antenna frequency bands. So essentially it's a 5G beamforming specific feature that for some manufacturers, they have implemented this functionality in their antennas. And at IXUS, we want to make sure that we support those functionalities in IXUS as well when we're doing our simulations. So what this allows you to do is under the antenna details level, or at the frequency band level actually, you can specify a certain angular segment, and that angular segment can then be attenuated by a certain dB amount. And that will then attenuate that specific angular segment based on that value. There's also ability to disable the functionality when you want to do a calculation like with or without those angular segments defined. All right, so the next one is the field point export feature providing contribution information. So this is a very nice way that we've implemented that you can, let's say, figure out what to do with a certain area that is overexposed, like what do you need to do in terms of which antennas do you need to attenuate or change. So what this feature allows you to do is place a field point at a specific position that you want to investigate, and then export that as a Excel file. And that will then provide you the as you can see here on the right hand side, the contribution of all the antennas and the frequency bands for that specific field point. And because it is in Excel, you can obviously then add a sum to figure out what the total value is there, and which will correspond to the actual field point. But the main powerful thing that you can do here is now you can recognize that, for example, this antenna, the main contributors to this field point, it would be B2 and B3, which has a high level of exposure contribution to this field point. And now you can recognize which antennas do you possibly need to attenuate to achieve compliance. The formatting of this is also pretty much the same as the antenna import in the manager as well. So that makes it a bit more user-friendly as well. The next one is the improved modeler performance with multiple polygon points. So in the past, placing a polygon or a polyline or some feature like that draws these grid lines will start getting a bit slow when you're getting to a lot of points. So this has now been addressed to after you've placed the point, there might be a small delay when you're getting to these high numbers of points, but once that is done, then it's completely smooth to render. Next feature is the export exclusion zone meshes to file. So during the previous release of IXUS, we did implement a .IGES file export of the exclusion zones. However, we have determined that that's not a very well optimized file format. So the files can get very large, and it's not there's not a lot of software that can read that file. So what we've done is we've essentially changed that feature to be a .dxf export, which is a much more common file format, and it's also a bit more optimized, so the file sizes are a lot smaller than the IGS. So it's important to know that this actually replaces the previous implementation of exclusion zone exports. So that then does not produce an IGS file anymore, it will produce a DXF file. Okay, so the next one is the ability to duplicate and transform markers and field points. So we've added the option for field points specifically and for markers that you can now move them, rotate them, and stuff like that, as well as, for example, duplicate and move. And obviously you have the option of adding multiple copies. We've also added a bit more interface change or the visual change to the field point, make it a bit more clear where it was placed and where the range is. So that was also implemented together with this, as well as just the straightforward duplicate option for environmental slices and antennas, not just the duplicate and move, which was previously the only option available. Okay, so the next one is the factor determine calculation method by checking if points fall within the near field block. So this is a bit of a complex one to explain because it's something not really that the user might interact with, but it's an enhancement in terms of how antenna models are created in IXUS. In particular for custom antennas, where the near field block is essentially the field samples that we calculate for that antenna in something like a full wave solver. But the problem was that with very low antennas that is very large in relation, like the actual radome size, which is larger in relation to the actual element array, those produced a larger far field than what that was actually realistic. So we changed a bit that to make it more flexible for our antenna team to model those antennas more accurately. Okay, then there's some other IXUS developments as well. In particular, the modeler installer improvement to speed up the installation. So previously there was a thing where it can actually install for quite long, like quite a few minutes. Now, I almost didn't want to include this screenshot. It almost felt a bit unrealistic, but it is 8 seconds to reinstall the modeler. Yeah, so that's much faster now. And then the other two is more of a supporting thing on our side as well. We added a date field to the portal to better track antennas when they were added. And then a banner indicating the required IXUS version for custom antennas due to this previous feature that I mentioned, or enhancement that I mentioned. You would not be able to use these antenna models with an older version of the modeler because it wouldn't recognize how this works. Then we also implemented this. I like to call it my little passion project. So it's the external VBA tool that allows user to generate terrain data in DXF format, and that can then be imported into the modeler. So it's a completely separate file to the modeler or the manager, but essentially it allows you to, for example, as you can see on the right hand side, you can specify a certain center lat long, and then the area around that, or the size of the block around that lat long. And what this tool will do is it will calculate a grid of lat longs around that center location, and then using a elevation API, for example, in this case, in this example, the Google elevation API, which will require a API key to be set up by the user. So it's just something that you mention. It then collects those the elevation data from all those points, and then creates a DXF file that can then be imported in the modeler, as you can see here on the right hand side, to represent the terrain. But I think that's going to be easier to demonstrate. So we'll move on to the demonstration. Okay. All right, so over here we have just a simple base station that I simulated before. And it's a bit difficult to explain how things are faster now, but the only way that I can think of is actually to run a simulation. So 5% public exclusion zone, and we can run that in simulation. So as I mentioned, with these very large custom exclusion zones, previously the meshing was very fine. So now that has been reduced, but still gets refined where necessary, and resulting in a much faster calculation than before. Actually, the single point source method will also actually help in this case, because typically for these exclusion zones, it will be also within the far field. And there you can see the simulation performed. So very brave to add a simulation like that into a webinar, but as you can see, that's now much faster. Okay, I'm just going to quickly change my settings to feet. So with the next feature that I want to illustrate, I'm quickly going to add an environmental slice to this section over here. Just adding a rectangle there to show. The reason why I'm adding this is that, for example, we have this blue public zone that is cutting into this piece of the building. So if we would want to, for example, avoid this, what can we do? So we can create, as an example, environmental slice, just using the same spatial averaging, maximum value in slice, and we can calculate that. Okay, so now that demonstrates where the maximum value is, and now we can actually place a field point on that location. Once again, same spatial averaging, and that should yield the same result. So what we now have is this option of export, file export, field point contribution data. And I'm just going to place it over here. Actually, let's put it there. That then export that. And if I go to that file location on my PC, I can open the Excel file. Oh, sorry, it's on my other screen, but yeah. All right, so now if we create a quick little sum here on this side, you'll see that will yield the same result as the field point or the environmental slice that we calculated. However, the powerful thing here now is that we can now recognize that at this specific location, if we want to ensure compliance here and we want to attenuate some of these antennas, we can now already see that attenuating these antennas are going to have no impact or it's not going to help us. However, some of the other antennas here, that will help, in particular these two, which is actually the 5G antennas or the beamforming antennas. So I'm going to do the lazy thing and I'm going to say, okay, let's see what 6 dB does, but I'm not going to properly type in the correct formula. I'm just going to do divide by 4, which is approximately 6 dBs. And now we see it, we're getting very close to exactly 100%. Okay, so let's implement that now in the modeler. Let's just see which antennas it was. It was B2 and B3. So that's B2 and that is B3. So the one thing that we can now obviously do is attenuate these by 6 dB to ensure that to ensure compliance there. However, this leads us to our next feature, which I'm going to demonstrate now. But first, I'm actually just going to determine what the angle is to that building over there. And I'm just going to use the rotate with this little cuboid. And as you can see, it's around about 30 degrees. Yeah, a little bit more. So let's use 30. Yeah, that should be more enough. Okay, and I'm going to delete this. So that brings us to this next feature, where if we go to specify calculation, model specify calculation settings, you can also reach that by going calculate, edit calculation settings. There is this feature now called enable segment attenuation. So if you select that, it will say segment specified active. Actually, that means that I've already specified them, which was actually a mistake on my side, but I'll demonstrate that. Details. So there's this button over here. I'm just going to delete that quickly so I can demonstrate it from the start. Okay, so as you may have noticed, when there's no segment attenuation that's specified, it will just illustrate like this, and then we can click this button. Then we can select add, and that will add essentially the full range of this antenna, which is like the full 360 degrees, full 360 in the horizontal and minus 90 to plus 90 in the vertical. But because I've determined that we actually only want to attenuate this section from 30 degrees, 6 dB, you can say it like that. So from 30 degrees to 180. For now, we're just going to do a full vertical range and select OK. And let's do the same with antenna. Oh, that was antenna 3, sorry. No, that was Oh, I probably didn't save it. Yeah, okay. Yeah, same with this one, 30 to 180, 6 dBs. Just make sure this one is also there, active, 30 to 180, 6 dBs. That's correct. Okay, so now we can simulate. This time I'm not going to do the 5%, and we can simulate that. So during the simulation stage as well, there will be a little indication of if there are segments defined, if you have enabled the feature. That if the feature is enabled but there's no sections defined, it will also say none specified, because obviously the attenuation is enabled, but there's none of those sections defined yet. Okay, and there's our simulation. So as we mentioned, we expected this to be around 100%, and actually it's rounding up from 100.8, so 101%, which is what we expected there. So as you can see now, this angular segment from here onwards have now been attenuated by 6 dB. And we can also run the lobe imprint at 3 foot. Yeah, that should also obviously show us the same result. This will be a very small little piece of lobe imprint on that geometry, but essentially it will be very small. Yeah, as you can see over there. Okay, so that then comes to our next feature, which is the export exclusion zones. Yeah, let's go over here. Example webinar, save. That then exports these exclusion zones as a DXF file. And if we go here and run that, I'm just using this free tool here. Yeah, there you go. Yeah, the exclusion zones have been exported as a DXF file. Okay. All right, so next one, polyline. That should be quick to demonstrate, but essentially, once you got to a lot of points, it will start getting very slow. You'll notice that when you place it, there's still a bit of a delay. It just the software needs to redraw all of these guidelines. But once you've placed the point, it is completely smooth to operate. Yeah. Okay. The next one is the duplicate option. So as I mentioned before, there was only the duplicate and option for antennas, but now there's the duplicate option, so we can just duplicate it at exactly the same spot. That will obviously now invalidate my calculations, but that's fine. The same actually with environmental slices. Used to be only duplicate and now it's also duplicate. However, field points and markers have now been edited a bit. So for example, if I add this field point over here, you'll see there's nice indication of where the placement was, as well as actually a snapping point there at the bottom. But now we can right click, so you can move and rotate, but you can also duplicate and move. So that makes it nice and easy, and you can select multiple copies and you add it like that. And actually the same goes for markers. So if we add a marker over there and I right click, duplicate and move, I can add a bunch of, duplicate a bunch of markers like that as well. Okay. And that is it for the modeler demonstration mostly. So we can close this and then we can go to this external tool. You can open that. Okay, so as I mentioned, there is some information here under the README section that you can also have a look at. Um, this is also a macro-enabled Excel file, so there's a few steps that you need to go through to make sure that this can actually run properly. But how this works is that you will enter your, if you're using the Google Elevation API, you will need to enter an API key over there that you need to set up yourself. But there are some other options as well. For example, this one is actually a um, free data source within the US, and there's some other options as well. But there's more details under the README section that you can have a look at. As I mentioned, with Google Elevation API key, you will need an API key that is filled in there. It's just hidden. So when you're sharing your screen, you don't show your API key to the world. But then you will enter your center lat long. You can change this to feet as well by using this drop down. And then the area around the site that you're interested in. For example, you're interested in a 200-meter size block. And here you can set the number of samples that you're looking into. So for example, if you want a finer mesh, you can increase this. That will then increase the total samples, which will be a more accurate mesh, but more complex. Let's just use 220, that seems fine. So once you click this button, this will then show you, say that KML file have been created. You can say OK, and it will then say that the coordinates grid has written to the Excel sheet coordinates. So it writes this grid of coordinates over here and then uses an API call. In this case, it was the Google API to collect the elevation data of all of those locations. Okay, so the KML file, if I open that, you see that will now, in this case, I used the Hollywood sign location as my center location because it's nice, a nice hill over there. I can actually turn the terrain on. Sorry. Okay. And this block then demonstrates the area that is going to be captured with the tool. So it's going to be this full terrain data that you're going to capture. The next step is here to generate DXF file. So that will then say data has been written to the XYZ as well as creating this DXF file in the same folder location. So what this does over here, it's now been transformed from coordinates with elevation to XYZ values, which then gets used to generate the DXF file. So what that means is because it's a DXF file, we have the ability in the modeler to say file import geometry, and we can say AutoCAD, and then we can select IXUS terrain grid. In this case, it's 800 faces. I highly recommend selecting here under advanced, the auto stitch faces option. That means it's just going to be one piece of geometry over here on the left hand side, not 800. And that imports the terrain. So how finely you would need to create this mesh, like the amount of samples that you need, will completely depend on the exact location that you're interested in. But essentially, you can get a very fine mesh, which will be a bit more complex, but or you can use a coarser mesh that's a bit easier to work with. But that allows you to get the terrain data into IXUS. Okay, so yeah, as I mentioned, it's like a little passion project that I was working on, but it's available to all of our users. We have placed this on the knowledge base, so you can download that and work with that. Yeah, feel free to let me know how that works. Okay. Okay, that concludes our demonstration. I just want to quickly just point you to our support links as well. In particular, our email address, which is support@ixusapp.com, which Carl is obviously manning. Always highly encourage users to use our help desk for support related issues as well, especially if it's a more of a complex subject where there's going to be a lot of back and forth. It just allows us to track the progress of that much easier, because it's very easy for emails to get, if there's a lot of back and forth of emails, context is very easily lost, where here everything is kept in one place in a help desk ticket. You can also schedule a call via this link, which we have changed from the previous Calendly. Yeah, comprehensive release notes available on the help desk knowledge base as well, as well as this Excel file that I mentioned just now. Yeah, and that's everything for this webinar. Thank you very much, everyone, for joining.